Welcome to Study Loop.
So here we're taking a look at platinum. We're told that platinum crystallizes in a face-centered cubic cell and that the radius of a platinum atom is 139 picometers. And we want to take this information and calculate the edge length of the platinum unit cell and then go on to use that to calculate the density of platinum. So the first bit of information that we should find is useful is the fact that this is a face-centered cell. And what that tells us, since it's a face-centered cell, is that the edge length of this cube is going to be 2 times the square root of 2 times the radius. So if we just plug in our given radius at this step, our 139 picometers, we find that the edge length of our platinum cell is 393.2 picometers. Now, the next part of this problem is a little bit more complicated because we want to calculate the density of our platinum, which means we want to go from the little bit of information we were given to grams per cubic centimeter. So we already have a good bit of information actually just from being told that it's a face-centered cubic cell and the radius. Because as we've shown here, we use the radius of a platinum atom to calculate the edge length of our cell, which means that more or less we already have the denominator of this fraction. Because we can take this 393.2 picometers and convert that to centimeters, which is 3.932 times 10 to the negative 8th centimeters, which means that the area of this unit cell, if we cube that number, is 6.079 times 10 to the negative 23 cubic centimeters. We already have the conversion factor that's going to get us to having this denominator. The other thing that we know about this unit cell is because it's a face-centered cubic cell, there are going to be 4 platinum atoms per cell. Now we can start doing some stoichiometry to convert this into something that's useful. So we need to go from atoms to grams, and from our unit cell to cubic centimeters. So we can take our 4 atoms, and the logical thing to go from atoms to grams is first to go from atoms to moles and then moles to grams. So to get from atoms to moles, we're just going to use Avogadro's number, our classic 6.022 times 10 to the 23rd atoms per mole. And then we're going to use the molar mass of platinum, which is 195.084 grams per mole. And finally, as we just showed, 1 unit cell is equivalent to 6.079 times 10 to the negative 23rd cubic centimeters. So now that we've lined this all up this way, atoms cancels atoms, moles cancels moles, our unit cell cancels our unit cell. And what we have here is a fraction. So when we do 4 multiplied by 195.084, divide that by Avogadro's number and the area of the unit cell, what we find is that the density of platinum is 21.32 grams per cubic centimeter. The important thing with problems like these is that you're taking all the information that you're actually being given. So while it looks like it's not very much to go with here as a face-centered cubic cell and the radius of the atom, you can actually determine a lot of things about this unit cell just based on the characteristics of one of these cells in general. So we know that this unit cell, because it's face-centered, that it has 4 atoms per cell. We can use that information to our advantage to get everything from something simple like the area of the cell, which we could have calculated, just knowing the edge length and the radius, but we can take that information and use it to our advantage to actually calculate the density of the element itself.